minutes.
All right, great. Well, yes, as Emma said, today's talk is called Data Science Workflow. Hello, everyone. I'm really happy to welcome you all to the summer internship program. My name is Michael Clifford. As Emma said, I'm a data scientist in the AICoE, specifically working on in the AIOPS group. Can you guys see my screen? Probably not, right?
No, we do not see your screen.
All right, hold on. Great. How about now?
Yes, awesome. You're all set.
Cool. So just to give you guys a little background about me, I started at Red Hat about 3 years ago, also as an intern, and I've been working as a data scientist ever since in the AICoE, and it's been a great experience. I live in Boston. If you're trying to find me online, either my email or LinkedIn or preferably GitHub is right here. So what exactly are we going to talk about today? I know that you all have been going through some pretty serious hands-on demos and things like that. So my talk is not really intended to be technical at all, but to kind of provide you a high-level introduction to how we see data science in our group and how we go about managing our work to collaborate on projects. So to that end, I'll go over a specific diagram that if you haven't seen before, we'll probably see a lot in your professional career about the data science workflow. We'll talk a little bit about how it relates to our group specifically. I'll go over some of the resources that can help you better understand the workflow and what you need to do. And finally, I'll go through a real project example that we'll all hopefully be working on, and put some of what I've talked about in the earlier part of the project into perspective. Also, don't hesitate to ask many questions along the way, and this doesn't have to be a lecture. It can be more of a discussion, but I'm also fine with it either way. So I assume that mostly everyone has some idea of what it is that data scientists actually do. In my opinion, I think that data scientists, in a nutshell, is really a software engineer whose primary responsibility is to ensure that a machine learning project is performing as expected, and that is achieved somewhat roughly by following the outline of these 7 blue boxes here. So as data scientists, right, we're usually given some high-level description of a business or research problem. Something like we want to give our customers better recommendations about whether or not they should replace a given hard drive. And then it's our job to try to kind of codify that request into a machine learning problem, right? So something like, can we encode the operating signals produced by hard drives in such a way that we can accurately predict the time to failure? Is it possible for us to build a useful regression model to solve this problem? And then hopefully we are also provided a clean and well-suited data set to start answering this question. But in practice, that's really rarely the case. And we spend a lot of time figuring out what data is actually needed to solve this problem, and cleaning it and so on. And so even though it's only the first kind of 2 boxes here, we do spend a fair amount of time on that side of the work. We then go through this the fun part, right? This iterative process of exploring data, trying to determine which features are the most informative, experimenting with a few different models, tuning their parameters until we feel that we have something that performs sufficiently well, given our validation data and given the requirements that we defined earlier in the project. And this is all often done, right, in an interactive Jupyter notebook environment, which I think you all are familiar with. at this point through the Open Data Hub and Rhodes demos, but it's just a popular environment for doing data science work. Um, but we also want our models to like be actually useful, right? We don't want to just say, okay, we trained some model and now we're done with our work. We want it to actually be useful and be used by others and like be included as part of an application. So it's also important that we go ahead and deploy our model as part of a service and that we're able to monitor its performance to make sure that it's continuing to operate as expected. And if its performance starts to decline, maybe due to data drift or some other reason, we can actually go back and start the like training, tuning, the validation part, like the middle chunk of this diagram a second time to kind of refine the model. So I think that kind of quickly sums up what data scientists, kind of the idea of what data scientists should do. That's still like a little bit vague. So part of what we want to do as part of like the data scientists and the AICoE is to try to create some best practices around how do you actually do data science? How do we move through these 7 boxes essentially? So it's specifically trying to put together the parts, all the parts that we need to go from some idea that somebody has to a final implementation of an intelligent application. And some bits of it like don't really sound a lot like writing machine learning code. I think that's like the important parts to make clear when you're talking about this data science workflow. And so that's things like doing like well-documented research in the problem domain, working with the business folks to like plan like what is the outcome of the application, how it should work, what is the deployment and like monitoring strategy that's going to be useful for all parties involved. So this is just all to really kind of point out to you that, at least in my experience, professional data science is really, I mean, probably all engineering is, but in my experience, data science is really multidisciplinary. So what are these steps, right, that we use to help us deliver data science projects? Like I kind of talked about already, the first thing is this project definition and business understanding. So this is this idea of we're working with an external group, like somebody else in Red Hat has some specific task, like hardware failure predictions, that we work with them to define what is actually the business understanding of the problem, what is it that they actually want, as far as do they really need a deep learning model, or would linear regression work just as well for the problem? Do they have the sufficient data to actually answer some of these questions? It might seem obvious, but it can be difficult to kind of clearly define what it is that what AI can provide to some of these folks. Then we want to make sure that we're actually aware of what is like the state of the art, right? So there's like a research and problem understanding phase, and that's just simply to say, it shouldn't take too long, but did a paper just come out this year that tells you that the most popular log parsing method doesn't work anymore? There's like been an improvement on it. Just gives us an opportunity to make sure that we are aware of like the state of the art for the particular problem domain before we start trying to write code and figure out some solution. Then there's obviously the data collection, preparation, and EDA step, where we go ahead and open up a Jupyter notebook and start to ensure that we have the right data, we understand the data, and that we can use it to solve this problem. So even though we maybe have access to the data and we have some problem defined, we don't want to just jump in and start trying to mess around with some model to figure out what to do, but just do some clear EDA so that we can explore the data and share that exploration with others. So that's kind of like the first 3 steps, I would say, though it's only the first 2 boxes there, I guess. That really gives us like the understanding of the problem, the understanding of the problem domain and the data that we're going to be using. So I think it's really important to have all those things well defined before we start trying to implement some proof of concepts. But once we do, that's again gets us into the fun part of writing some Jupyter notebook where we start to implement a model. I then want to go ahead, like I had said, deploy this as a proof of concept service. So we don't necessarily need to have a fully robust application deployed, but I think it's important as data scientists to get feedback on our models. And you all will learn this hopefully quickly, that a lot of the work we do is not actually supervised learning tasks, and a lot of it's unsupervised learning. So how do we actually evaluate these models is kind of difficult, and uh, getting user feedback is one way to do this. So having a deployed model that a SME of some kind can actually interact with and give us feedback is really important. And then that will evaluate the application as to whether or not it's successful, and then we can hand it off to that team. We don't necessarily want to be responsible for managing the model and application indefinitely, but it's something that we can hand over to them. So again, while working on data science projects, these like types of things that are getting made, right? It's not just purely TensorFlow code essentially. So it's like writing project documentation, um, making slides like this to like communicate research decks, to help help others learn what it is exactly we're doing, or communicate some need. We're also developing Jupyter notebooks, obviously. Um, we also create these like automated workflows and pipelines to run and execute our notebooks in some kind of application like order. Um, we use OpenShift to deploy applications and get feedback from our users. And we also create dashboards with tools like Grafana or Superset to both like monitor application as well as be like a presentation layer for some end user who's interested in the output of our work. We also, are doing code reviews, making sure that each other's code is um, works, as well as dealing with a lot of issues and PRs to discuss ideas and implementation approaches for our work. So these are kind of all the things taken together that I think constitute what gets generated during like the data science workflow. And so again, so what does this mean for us as data scientists in the AICoE, or more specifically, I guess, in the AIOPS group where I work? And this might be a little bit of a tangent, but I think that it gives context for why it's important for us all to know about OpenShift and everything beyond just solving some AIOps task. But I think that we really serve like two purposes. And so, yeah, the first is to actually do this data science work and develop tools and solutions for automating IT operations, as well as to define some of these best practices. So the other thing that we do, right, is to define some of these best practices for cloud native data science development. So Marcel already gave you all some good intuition about what AIOps is about, so I won't go into it in too much detail here, but just quickly to reiterate, like we're primarily concerned with all of the signals that are produced by computers, and that's primarily like OpenShift clusters, as well as the humans that develop and maintain them. So that's data types like logs, metrics, configuration files, bugs, code. And that can also include like developer mailing lists, things like that. And then we try to leverage this like array of multimodal data and data sets that essentially continually describe the state of these systems to work on problems like anomaly detection, predictive alerting, failure type classification, and ultimately this like self-driving cluster. However, like while we're doing this work, I think that's important that we all have a shared framework, right? Or like a workflow that we can rely on to keep ourselves really organized and on task. And since data science is kind of fairly new discipline as compared to maybe more traditional software engineering, I think part of what we do is try and define and codify some of these best practices. Um, but like, what are the best practices for developing data science projects, right? Like both from an organizational standpoint and a tools and technologies perspective. As I just mentioned, I think this is still a little bit of an open question. So knowing what is the proper way to review a data science PR, how should data scientists organize their repositories to allow for simple collaboration and easy reproducibility. What are the right tools for training models versus deploying models? How should we monitor and update models that have already been deployed? How do we like visualize our work, right? Like, so what are some of these? Like, there are a lot of answers to these questions. There are a lot of tools out there, but which should we be using, like, and using in concert? I think is what is we're trying to figure out. So, Open Data Hub, which I know you've all heard a lot about over the last day or so, is one of these platforms that's aimed at helping data scientists like us develop these sorts of cloud native intelligent applications. Um, and part of what we do as data scientists is actually use Open Data Hub on top of Operate First when we can, to help refine it and ensure that like features meet the needs of real world data science work. And we can provide feedback and suggestions to like the upstream project. Cool. So yeah, so just to quickly recap, as data scientists in the AICoE, kind of have a twofold goal of both developing AIOPS tools to support Red Hat and like the wider open source community, as well as to use the Open Data Hub platform and ensure that it like meets the needs of real world use cases. Cool. So again, how do we actually do this? What are some of the kind of best practices and tooling that we've come up with so far? So the first thing that I want to show you is the data science workflow GitHub repository. This is where we aim to store all of our documentation about data science stuff. I'm not going to go through like everything that's in here, but I do encourage you all to take a look when you have time, and feel free, or I very much encourage you to open issues if you think that something is missing or unclear, or even if there's like a typo here. We try to do everything in GitHub, even like documentation development. So it'd be really useful. So this repository. Like I said, you all should go to it. You'll find that there's documentation here about the projects we're working on, how to create and deploy Jupyter Hub images. If you want to know more about the data science workflow, I think there's a video attached here that I created a while ago that you can look at. How to review data science code, all of that kind of stuff is here for you to review. The more important thing that you all should be aware of as you're starting new data science projects is something called the template repository. So this is the base from which we create all of our data science projects. So when you're working on a new project, you should use this template, you can call it whatever, and create a new repository. And the benefit is using this template repo is a number of things. I mean, primarily before we had this, people were basically free to do whatever they wanted as far as organizing their work. And it just made it difficult for other people to understand what was the point of the repository. And so yeah, so when we all use it, we know where to look for notebooks, data, all of that. You can see here for documentation about how exactly to use it. The other thing, this is also like a living project. So as the Thoth team develops new tooling to help us with our CI process to ensure the quality of our data science code is good, and um, that the code we write actually like builds. Um, there are a number of YAML files that you don't have to understand now, but just know that they come included with the notebook that make it very easy for us to ensure that all of our kind of code works correctly with the Thoth tooling that we have. The other thing to be aware of as far as like the data science workflow, more specifically like GitHub workflow, the way that we work now essentially is to have everything in GitHub. Everything exists as an issue. So if you plan on working on any part of those 7 steps that we talked about earlier, that can be represented as an issue. The issue can be talked about, and we can like work on it together, refining it through comments here. And once you start to do that work, when it's ready to be merged, either as documentation or actual working code or whatever it might be, there'll be a PR that's generated, and that will go through a review process to make sure that it's good. Basically, I'm sure it'll all be great, and then it can get merged into the documentation. One thing that I hope is obvious to everyone here is that this GitHub workflow should be identical for software engineers as it is for data scientists. I think another kind of tenet of what we are trying to do is make sure that data scientists are software engineers, essentially, just with like a minor specialization in model building. So a lot of the expectation on how to contribute to work should be pretty similar to software engineering. Cool. So again, data science workflow. This should be a public repository. Encourage you all to take a look at it and open some issues. So now that I've given you all a general sense of what data scientists do in the AICoE and why we do it, I want to give you a quick introduction or a walkthrough of like a real project that we're working on, and hopefully you'll have contribute to at some point this summer to kind of put into practice what all this stuff that I've just been talking about for the last 20 minutes actually looks like. So we have this operate first.cloud website where this is kind of like the front end of our project. We have, so I'm not going to go in, I'm kind of running out of time here, so I'm not going to go into huge detail. But basically, as one AIOPS project that we're working on is AI supported continuous integration, where we are like leveraging some open source CI data that's being generated by the OpenShift platform to kind of bootstrap a community around open source AIOps. So we have this site here, but it's really everything's backed by our GitHub repository. So this is all just mirrored by documentation that we have on our GitHub repository. So if we go to the project repo, I hope the first thing that you all realize is that it looks very familiar. It looks like the template repo that we just went through. So now any of you should be able to come here and know where the notebooks are, where to find the data. If you're interested in contributing to the project, there's, again, documentation, very clear how to contribute, or hopefully very clear. If not, submit an issue and let us know why. And then the way that we actually work on these projects is everything's represented as an issue. Like I said, it's gonna restructure the visualization notebook. We have some description of what we need to do. There's a discussion that we have about the best way to go about it. And then we actually do the work. And that gets represented in the form of a pull request that, this one maybe is fine to show, where somebody has submitted some, let's see if this will work, some changes to the code. and we can have a discussion about it and determine whether or not it's ready to be submitted. If not, we'll go through revisions of changes until it is. And we can also use something like ReviewMB, which is a really nice tool for data scientists. I don't know if you saw the other rendered diff, but it was pretty difficult to parse. So we can use ReviewMB to do code reviews on notebooks and add comments and all that kind of fun stuff. Let's see, anything else? And again, the way that all of this is tracked for all of us is by using these project boards. I'm not sure if you're familiar with any of this, but these are all connected to issues, and we can keep track of what's currently being worked on, who's working on them, and moving them through from like backlog to the done column over hopefully a short period of time. I think if you're on the AIOPS group, you should have created one of these with your mentor that you'll be using for the summer. I mean, again, it's just like a very convenient way to keep all of our work kind of in one platform, essentially, on GitHub. Cool. So I think that's really all I wanted to share with all of you at this point. Just know, I think that the main takeaway for that last bit is that GitHub serves as kind of our central tool for storing, orchestrating, and communicating with each other. There's a couple of other things that I didn't go into here that I think Andrilla and Karan will share with you tomorrow about reproducible notebooks, as well as like automated pipelines and things like that. So yeah, just to kind of sum up, I hope you all have a better sense of what professional data scientists kind of do, what that means for the kind of work that we specifically do on our team, how we try to keep ourselves organized and productive as we figure out the best practices for data science, which I guess is like a relatively new discipline. So cool. So yeah, thanks. Any questions?
I just have a quick question.
Go ahead.
I was just curious to see what, I guess like you kind of mentioned that the reason why you're using like the table structure and like for like planning out like to do like that whole structure within GitHub was just for keeping it all on one platform. I was curious to see if y'all had tried anything else and if like whether it pretty much has the same functionality in that and your experience with that.
Yes, we've tried lots of different things over the couple of years I've been here. I think the thing that we had landed on that we found to work the best was Trello. I don't know if you've used that.
Yeah.
However, Trello, at least the way we were using it, is independent of GitHub, and these GitHub projects are almost exactly like a Trello board. So it's a really good fit, at least for our team. I know there's also Jira, which is used by other teams. I think even within maybe the AICoE, maybe Open Data
Hub. Like EDA and like EDA and them use it a lot for like their
I know the internal teams definitely use it. I don't know.
Right.
I think we were really had our hearts set on like single platform or like fewest platforms as possible. So that's why we landed there.
Okay, sweet. I just was curious. That's something that I'm kind of working through right now with some of the stuff with OSPO.
Yeah. Cool. Great. Well, I don't know if there's no other questions. Looking forward to working with you all this summer. If you have any questions about any of this stuff or anything at all, don't hesitate to reach out to me at email, or obviously I'm on Google Chat like all day long. So yeah.
Awesome. Thank you, Michael. And if you guys don't have any questions, we can hop off and reach out to us in case you do come up with any questions later. The sessions will all be recorded and updated on the source page. So if you don't know where to find it, please let me know. And with that, I think we can conclude for today, and I will see you all tomorrow. It's going to be the last day, so I hope you all get the most out of it as well. So, have a nice day, everyone.